Welcome back, Algebra 1. We are on our last section of this hodgepodge of radicals and all that fun stuff. And this is really going to jump all over the place because we are actually doing a little bit of 10-2, but primarily 7-5. So 7-5 is rational exponents. Okay, so a rational exponent, all that is basically a fraction, an exponent that's a fraction. And so we're going to look at that. If you don't remember like the parts of a radical, which we did in like our last notes from, here, the index number, the radical, and the radicand, just like kind of maybe look at those for a second because I'm going to be using those terms. But let's start. So rational exponent is the same, like I said, as just basically an exponent that's a fraction. So if you saw something like this, x to the m divided by n, we can rewrite that using both exponents and using radicals. So to rewrite that, your denominator, the n, always now becomes the index number. So x, the base, is going to become the radicand, the number that's within the root. And like I said, so the denominator n is going to become the index number. And then m, the top or the numerator, is going to become the exponent. And sometimes you'll see the m on the inside here. I actually like to think about it on the outside. I think it helps more when we're simplifying. So that's how I do it. So again, let's kind of reiterate that point, what we said. So the numerator becomes the exponent. And then the denominator becomes the index number. So the denominator becomes the index number. Okay, so let's kind of put that into play and what that means. So first what I'm going to do is I'm going to convert a root to a rational exponent. Okay, so if I gave you something like this and I said, okay, the fifth root of x all squared, how would I write that? How would I write that with using rational exponents? Okay, so let's think about that. Okay, whatever is inside the square root is always my base. The exponent is always the number on top. So 2 is going to be my numerator, 2. And then the index number, 5, is going to be my denominator. So it's the same thing. X raised to the 2/5 is the same as me saying the fifth root of x squared. Okay. So what I want you guys to do is I want you guys to look at this next one. Okay, so if I gave you the fourth root of AB, okay, how would we write that as using a rational exponent? So first, I think, okay, what's inside the square root? Well, what's inside the square root is the entire AB. So I'm going to actually just start by putting that in parentheses. And then I think, well, what's on top? Well, what is the exponent? When there is no exponent, what exponent can you always assume is there? And that's 1. So the number on top is 1 divided by the denominator, or divided by the index number. The index number is 4, so 4 is going to be my denominator. So we can write the fourth root of AB as AB to the 1/4 power. Okay, last one in this section. I want you guys to rewrite. How would you rewrite the square root of x? Think about how you would rewrite the square root of x. And if you're thinking, I don't know, where are all those numbers? Well, remember what we know. So, okay, what's inside the square root is x, so that's going to be my base. The exponent, well, there is no exponent, so when there is no exponent, we can assume it's 1, so that's going to go on top. And then there is no index number, but remember, when there is no index number, we can assume the index number is 2. So x to the 1/2 is the same as me writing the square root of x, which is super, super important, and it's one that we use often. I'm actually just going to rewrite that above this or below it. And let's write it above. The square root of x is the same as x to the 1/2. That is so, so, so important. It's something that like we really, really do. Like I use it a ton in honors algebra 2. We use it in algebra 2. Just knowing that and remembering that is super important. Okay, so let's instead, now we were going from roots to rational exponent. Let's go backwards. So let's go rational exponent to root. Okay. And there we go. Okay, so let's look at our first example. So I want you guys to think, if I gave you x raised to the 4/5 power, how would I rewrite that as a root? So think, what would be the index number? What would be the exponent? And go from there. Okay, so if you're thinking, okay, we know what's inside the root is going to be x. The base is always the same as what's inside the root. And then I think, okay, so my index number is always going to be my denominator. So my index number is 5. So this is going to be the 5th root of x. And then what's the exponent? It's going to be raised to the 4th power. So without all the colors, the 5th root of x raised to the 4th power. That would be my final answer. Okay, so let's look at another one. Let's actually bring numbers into this. What if I gave you 16 raised to the 3/2? So what I want you guys to do right now is just pause me here and rewrite this as a, like with a radical and the exponent. So rewrite it just like we did. We went from here to here. Okay, so what's inside the root is going to be 16. My index number is the denominator is going to be 2. We don't need to write it because whenever the index number is 2, you don't have to write it. And then 3 is my exponent. Well, Now with numbers, we can take it a step further. What is the square root of 16? The square root of 16 is 4. And then I can cube that. Well, what's 4 cubed? That's 4 times 4 times 4. That gets me 64. So 16 raised to the 3/2 power is the same as 64. Okay, let's try another one. Okay, what if I gave you 81 to the 1/2 power? Remember, what do we know that 1/2 is the same as? Remember, we wrote it and highlighted it up here. Okay, so if you're thinking, okay, I know 81 to the 1/2 power is the same as the square root, or if you need to rewrite it and go, okay, we know what's inside the square root is going to be 81. We know the bottom number is going to be my index number, and we know the top number is going to be my exponent. So if you need to write it out like that, that's totally fine. If you have it memorized, that's great too. So the square root of 81, what do we know the square root of 81 is? Square root of 81 is 9. And 9 to the first power is just 9. So 81 to the 1/2 is the same, like I said, as just saying what's the square root of 81. Okay, I want you guys to try this one on your own, and that will be it for this last section here. Okay, so what is 27 raised to the 2/3 power? So I want you guys to pause me here, try that one on your own, and then come back and check your work. Okay, so you should be checking your work. What's inside the square root is a 27. And remember, the denominator, the 3, is my index number. So we're thinking, what's the cube root of 27? And then we're going to raise it to my exponent, which is 2. So what is the cube root of 27? Well, the cube root of 27 is 3. And then 3 squared is 9. And that's my final answer. Okay, so that's it that we're going to do with rational exponents. What we're going to talk about now is the part of 10.2 that I just wanted to finish up with, which is simplifying radicals with variables in it. Okay, so we're going to jump into that. It's going to be the last section, the last thing that's going to be in this like little hodgepodge unit. Okay, so that's going to be roots with variables. We're going to put simplifying. Roots with variables. And all that means is that there are going to be variables now inside the root. And we're going to use what we know about rational exponents, or sometimes I call them fractional exponents. We're going to use what we know about that to help us here. Okay, so I'm just going to get into an example. And again, we kind of have to like use our information that we already know from our like prior units and use that information to help us and apply that here. But then we're going to also just kind of do some new stuff too. Okay, so we're going to start off here with the square root of 36x to the 4th. Now, again, there's a lot of different ways of doing it, and I'll show you 2 ways of doing this. But I always just kind of start by looking at the number by itself. So I just break it up into thinking, okay, what's the square root of 36? And then I'll deal with the square root of x to the 4th. Well, we know what the square root of 36 is. The square root of 36 is a perfect square root. It's 6 times 6. And so we know, okay, we're going to get a 6 that's going to be able to come out of the square root. Now, using what we know about radicals and being fractional, like rational exponents, I can rewrite this as x to the fourth to what power? The square root we know is the same as 1/2. We have that information up here. Well, throwing it really back to exponents, a power to a power, what do I do with my exponents? I multiply them. What's 4 times 1/2? Well, 4 times 1/2, or it's the same as thinking 4 divided by 2 gets me x squared. And so we can take out an x squared. And so the square root of 36x to the fourth is 6x squared. So you can always, like a shortcut or a trick is always taking, like with the variable, whenever it's a variable, you always like divide by the index number. Okay, so divide the exponent on a variable by the index number. Now, this is like always how I think about it. But like I said, there's another way to think about it. And it's kind of thinking about it with a factor tree. So I'm going to just show you like another method. So I'm not going to show you the other method with like the 36. But I am going to show you with x to the fourth. So we know a square root is trying to find a group of 2 of the same things. And with 36, we know, okay, that's 6 and 6. 2 of the same things. But then with x to the fourth, we can write that out as a factor tree. X to the fourth is x times x times x times x. And so then I look, okay, 6 and 6, there's the pair, the 6 comes out. And then I look to see, are there 2 of the same things? Yep, there's a pair of x's. But wait, there's another pair of x's. And so x times x gets me x squared. So it gets you the same thing. So if you want to write them out, or if you want to just divide by the index number, whichever one makes sense to you, go with that. Like, do what makes sense to you. Okay, let's try another one. What am I on? 9. And let's go with 8x to the 7th. And going forward, I'm just going to show you using like the division method. But if you want to use like this method, that's totally fine. Do what you like, what's best for you. So the first thing I like to do is just start by breaking it up into each part. So we have the square root of 8 times the square root of x to the 7th. So I think about, okay, square root of 8. So I think about what's the perfect square root that divides evenly into 8. And I know that that's going to be 4. 4 times 2 is 8. Okay, we know what the square root of 4 is. The square root of 4 is 2. And then 2 is left over. So I'm just going to kind of leave that for right now. Okay, then I'm going to look at x to the 7th. Okay, so remember, we look at what our index number is. So our index number here is 2. When there is no index number, we assume the index number is 2. And so I'm going to take my exponent. Sorry, I blanked there. I'm going to take that 7 and divide it by 2. Well, 7 divided by 2 is 3 with a remainder of 1. So what that's going to look like and how that's going to play out in my answer is that means that it goes in evenly 3 times. So 3 x's can come out. So this is the number of x's that can come out of the square root. And then the remainder, so there's a remainder of 1. So that's the number of x's that will be left inside the root. Okay, so what that means is 2x cubed can come out because we know the square root of 4 is 2. We know the 3 is x cubed. And then what's left inside the square root is the 2 and then 1x. X to the first, you don't need to write the x to the first. And that is my final answer. And that's it for number 9. Okay, let's do another one together. Okay, so let's try, I'm actually just going to flip the page because I feel like I'm kind of running out of room here. So I'm going to turn it over. What am I on? 10. Okay, so for 10, I'm going to give you, so we have the square root of 45 x to the 5th. Okay, so I'm just going to kind of, again, like walk you through this one. So I start by thinking about just 45. So I break it up. We think about what's the square root of 45? What's the square root of x to the 5th? So the square root of 45, I think about what's a perfect square that goes evenly into 45. And we know that that's 9. 9 times 5 is 45. Now I'm going to kind of like draw it down, show it down here in a little bit different way too, so you guys can see it and keep it separate for a minute. So, okay, we know that the square root of 9 is 3. So the square root of 45 would simplify to be 3 rad 5. So then we deal with, okay, well, what about x to the 5th? Well, again, we know the index number is 2. So we take the exponent 5, divide it by the index number 2. 5 divided by 2, it goes in evenly twice with a remainder of 1. So that means x to the 5th simplifies as x squared with 1x on the inside. So the square is here, the 1 is here. So the remainder is the leftovers. The 2, the number that goes in like evenly, is the exponent. And then we can just multiply, combine what's like the outside and the outside is both 3 and x squared, and combine the inside and the inside. So rad 5x. And that's it. That's my answer. Okay, so why don't you guys try this one? I'm going to fold my page so I have it even because I like it like that. Okay, so if I gave you the square root of 27 x to the 9th y squared. Okay, so now there's an extra variable in there. Doesn't mean anything different, but all that means is what we're going to do is we're going to look at it in 3 parts. What's the square root of 27? What's the square root of x to the 9th? What's the square root of y squared? So if you're feeling good about this, I want you guys to pause me here and try 11 on your own. If you still need that extra help, that's fine. I'm happy to work through the problem with you guys here. But, if you can try it on your own, try it on your own for sure. Okay, so 27, we think about how does that break down? What is the perfect square that divides evenly into 27? And that's 9. We know that's 9 times 3. So we know that the square root of 9 is 3. So this simplifies to be 3 rad 3. Okay, and then we're going to break up x to the 9th. So we take the exponent, divide it by the index number. The index number is 2. And so we get, it goes in 4 times with a remainder of 1. So that means x to the 4th is going to come out. X to the 1 is going to stay inside. And then when we move to y squared, well, we just take again. So here we took the exponent. We're just going to take the exponent and divide it by the index number. Well, 2 divided by 2 is just 1 with no remainder. So that means that y to the 1 can come out and there's nothing left over. So there's nothing left over in the square root. So then we just combine what's on the outside, 3, x to the 4th, and y. And then what's inside is 3x. So I just combine what's inside. And that is my answer. Okay, we're just going to do one more, and then we will be done for these notes today. Okay, so this one is going to be the cube root of 32, x to the 4th, y to the 9th, w. Woo, now there's 4 parts here. So again, I'm just going to break it up piece by piece by piece. You don't have to break it up. If you can do all of this like in your head, great. If you can't, break it up. Take it just part by part by part. So we're looking at the cube root of 32. So that means I'm looking at what's a perfect cube that goes evenly into 32. The cube root of x to the 4th. The cube root of y to the 9th. And then the cube root of w. Okay, so I think about what's a perfect cube that goes evenly into 32. Remember, your perfect cubes are 1, 8, 27, 64, so on and so on and so on. But I know that 8 is the perfect cube that goes evenly into 32. And we know 8 times 4 gets me 32. So I can take out the 8, and the 4 is going to be left inside the cube root. So the cube root of 8, what times itself 3 times gets me 8 is 2. And then be careful here. Remember, what's inside is inside a cube root. So what's cube root 4? Now with this one, okay, it's same thing, but we have a different index number. The index number is 3 because it's a cube root instead of a square root. So it doesn't change the process. It just changes what we're dividing it by. So we take the 4 and divide it now by the index number, which is 3. So 4 divided by 3, that goes in evenly, 1 with a remainder of 1. So what that means is 1x can come out and 1x is left, remember, inside that cube root. Okay, then let's move to the 9. So 9, we're going to divide by 3. So 9, the exponent, we're going to divide by the index number. 9 divided by 3 is even. It gets me 3. And so that means that y to the 3rd power comes out and nothing is left over. There wasn't any remainder. Okay, and then last one, well, this exponent is 1, and it doesn't go in evenly, so it's none with a remainder of 1, really. It doesn't go evenly at all. And so if it doesn't go evenly at all, we just leave it inside the cube root. And so my final answer, we'd write it as 2x y cubed, and then all inside the cubed root is going to be 4x and w. So I really I know these seems kind of overwhelming because there's a lot of parts, but I really even when I'm just doing this on my own, I just take it piece by piece by piece. I look at the 32. I look at the x to the fourth. So I almost treat them as four separate problems and then bring it all together at the end. So if you guys have any questions, this is really our last of the hodgepodge of units here. But if you guys have any questions, we're going to be quizzing on this next week. So if you guys have questions, come to office hours, get the help that you guys need. I'm happy to help. And that is that. So I hope you guys have a good day. I hope you guys have had a good week. Yeah, hope everyone's well. I miss you guys.